Hello, everyone. Thanks for joining us for this session. It's called The Road to Autonomous Cloud Security Remediation, where we are going to talk a bit about how AI is going to impact the cloud security remediation process. Um, so first, just a bit about myself. I'm Tomer Schwartz. I'm co-founder and CTO of DAZ. In DAZ, we focus on this particular space quite a bit. So I spent the last few years exploring the problem space and focusing quite a bit on different approaches to this problem. Some of them include generative AI, which we'll talk a bit about in this presentation. But before we begin, I want to give you a quick reminder of not so long ago history, right? Back in the data center days, we had huge organizations, Fortune 500 companies, with just a handful of applications and probably a couple different development teams. And they had a fairly simple process of being able to maintain that infrastructure and maintain those applications. But fast forward a few years later, now with the cloud, obviously every single company is investing quite a bit. We're seeing customers with hundreds and thousands of different applications that are continuously deployed and modified. It's not really surprising that based on some of the estimates, by the end of this year, the cloud spend is projected to reach almost $600 billion. We're seeing the increase in how much of the IT spend is actually being spent on cloud. And with that, the cost of a cloud-based breach is becoming higher and higher, with an estimate here that shows $4.8 million for the average cloud breach. But if we go back to the old times with the old model, back then, let's say that we had a critical vulnerability that is impacting our environment. To be completely frank, no one actually did anything with that, right? Which led to a complete chaos, a lot of different attacks, a lot of different breaches that are just based on disclosed vulnerabilities that everyone had known of, but no one actually acted on them. Not that it was very difficult to actually fix those vulnerabilities. Let's say that we had some kind of an operating system vulnerability, or maybe a vulnerability in a particular library. Back then, we could just SSH into the right host. We could upgrade the dependencies, the libraries, the operating system, and technically, it could have eliminated the possibility of a breach. In reality, once the industry started to pick that up, there was quite a bit of a golden era, maybe 5 to 10 years ago, where people started to talk quite a bit about automated remediation or automated response, where we would just build automation to log into all of these servers, to all of these machines, and automatically patch them. Um, what happened there is that very quickly, people started to realize that modifying the underlying infrastructure and the underlying applications, or underlying operating systems and dependencies, may not be quite a good idea for running applications. And sometimes they break. Obviously, this got to a lot of unhappy engineers that had to work tirelessly to figure out why did their application break all of the sudden. Why are we seeing a production outage? And very quickly, people got a very negative knee-jerk reaction to the term automated remediation, because at the end of the day, there's a lot of risk with doing these kinds of things. So I think that what it led to is that in our industry, it led to this very very problematic risk calculus that was not really promising, right? either we change production and risk that it breaks, or we just keep it at it. We just keep it as is and risk that the application will be breached. Um, and I think the majority of the market eventually landed on, hey, let's just decide not to break applications, and opt instead to take the risk of, well, maybe there will be a breach in the future, but as long as there is no right now, we can figure out our threat model. We can figure out what kind of compensating controls we have around this. I think a good example of this is Windows XP on ATMs, right? This is still happening. And I guess that for them, that risk calculus goes for, hey, I don't mind using a completely out end-of-life operating system with known vulnerabilities because the threat model allows me, and I don't really want to risk the fact that the ATM will stop working. So I think, to me, it's really a discussion around trust, right? Because it's really a matter of, hey, can the business trust a machine or even a human to change our production environment by itself? Probably not. If we ended up with the same processes and with the result that we can't really modify the environment without a very heavy lift to involve the engineering teams and the infrastructure teams to make sure that everyone is aligned. It goes through testing. It goes through the typical QA process to make sure that we're not really impacting the environment at all. It's a very costly process. And it boils down to the fact that the risk of not going through that process is much greater than the reward. The risk of a production outage due to a naive automated change or a naive manual change is just greater than the reward of having our environment secure. So with that, we're here to talk about AI in our CSA AI Summit. And generative AI is a really good model for us to try to improve that process. But does it mean that everything changes? Well, not quite. We can do a lot of great things with generative AI and being able to propose the remediation guidance and analyze a lot of data and even generate configuration fixes or code fixes, but the risk remains the same. We're just improving the process or improving the mechanics of the process to be completely accurate. It can produce wonderful results, but sometimes the machine is still wrong. It could be because of simple mistakes, of errors, of false training data. Hallucinations is one example from the AI world. Sometimes we even see adversarial inputs. Depends on what is the process that actually executes the generation of the output. In this particular example, this is just a simple one from ChatGPT. And if you're wondering which other countries start with the letter V, then I thought of Vietnam or Venezuela, but there could be plenty more, but definitely more than 2 countries. So if we go back to our story, what I claim is that it is and it isn't an AI problem to get to that cloud security nirvana, right? First, it's a risk management problem. And we need to show that our remediation program that we're proposing can actually be trusted. It's robust enough. It's not going to break anything or not likely to break anything. And we need to prove that the risk is less than the reward in this equation. So first, we need to appreciate that modern cloud environments are no longer mutable. What it means is that if there's a particular vulnerability in production, let's say we have this particular CVE affecting our environments, it might affect a particular workload or a particular container. we can't really modify the environment as is with immutable infrastructure, with infrastructure as code, with containers, with all of the modern technologies that are typically being used in the cloud. It means that we can't really change something in production directly. We need to find where that artifact is defined in our code base. So, for example, if there's a running container that is currently vulnerable to a particular CVE, we probably need to find the right Docker file, or we probably need to find the application that runs on top of that container and figure out what kind of dependencies they have and how they bring those dependencies into the image. We need somehow to link between what's happening in the cloud environment and how it's represented in the code. We need to find the origins of these artifacts. In other words, we need some kind of an automated root cause analysis process. Once we have that, we can fix the problem, we can upgrade the package, we can change the configuration in code, redeploy the application, and verify that the change that we've done actually fixed the underlying vulnerability. It's still not a very trivial task for an LLM. We need to get a lot of data, and we can't really get it wrong, because if we fail to find the right root cause, we might spend a lot of iterations and a lot of time in generating proposed changes to the wrong location. And right now, most of the famous LLMs like GPT, currently they're not doing an amazing job of binary analysis. Other models could be more suited for this job, not necessarily from the generative world, by the way. But let's assume for a second that we already solved the root cause analysis problem, and we have ways to link between what's happening in the cloud and where is that defined. Then technically, from that point, we could ask an LLM how to fix a particular vulnerability. So if we're seeing a CVE in a container, we can ask them, hey, how do I operate that container so potentially that vulnerability is no longer affecting it. Again, even that process, there is quite a lot of nuance. We will probably need to ask again and again to get not only the right answer, but the most right answer for our particular circumstances. And again, with LLMs, the more context these models have, the more context these models are trained with, the more tweaked the prompt will get better results. And we want very good results to be able to actually deploy the application safely and make sure that it's no longer vulnerable. So a simple model for this is this. It's probably very, very similar to any kind of a DevOps pipeline that you've seen, a very simplistic one, I know. But I think the primary thing that I want to say here is that existing CI/CD models play really nicely into this mix. Because if we already have a fix at the root cause, we can use the existing platform to build, test, deploy, and then feed back the results of that process into a generative AI model. So assuming we managed to build the application and get it to run in, let's say, a lower environment, doesn't really have to be production, we now can rescan the environment and see if the vulnerability is no longer affecting us. If not, we can take the scan results and feed it back to the model and hope for another proposal for a change. And if we do this process again and again, hopefully we'll get a clean scan at the end of that process. This is the goal for a cloud remediation solution. We want to be able to generate the right fixes, to build that remediation plan up to a point that we know that in the last iteration, the application is no longer vulnerable. Now, the fact that code gets built and the fact that it passes a test suite doesn't really mean that it actually works. There's a lot of nuance there as well. But that could also be the case with a real human engineer making changes. If our test suite is not robust enough, or if our generative AI model tries to change the test suite directly just to be able to pass this, then yes, we'll get some very interesting results here that are definitely not what we've intended. But to be able to really implement a model like this in reality, it goes back to building confidence and making sure that the right application teams, the right DevOps teams are actually seeing and improving these changes. So ideally, in the models that I'm familiar with, in environments that are already utilizing similar architectures, what they typically do is that they surface this as a pull request and ask the right engineer if this makes sense to them, right? They can decide if there's no way in the world they can accept this change because it's making a lot of different modifications in the code base. It's modifying the test suite directly for no good reasons. They can just decline that change. But if it's a simple fix that eventually changes the configuration file or bumps up a package version, they can very quickly look at this and say, well, if it passed the test result, then it's probably the same thing that I would have done myself. So let's just approve that change and move on. So what's important about this process is to make sure that we're building more and more confidence. If we're remediating vulnerabilities continuously with such model, and the results, the outputs of this architecture is very accurate, then over time, we'll gain the confidence of the DevOps teams, of the application teams, because they will see that that in 90% of the cases, they just approve the automated fixes. This builds the level of confidence to decide what kind of fixes we can actually promote automatically. So I don't think that right now this model is definitely applicable to as a blueprint to your company, for example. There's a lot of different nuances here, right? But I believe that in a couple of years out, we'll be able to implement such models more and more broadly in the enterprise. But even to be able to build something like this, we need to remember that cybersecurity is also a very fast-paced industry. And right now, generative AI models are by themselves, they're not, well, I would say that by default, they're not suited for that particular use case. It requires quite a bit of tweaks. In 2022 alone, we've seen a record number with over 26,000 CVEs reported. If we expect our AI model to know about all of this, it means that on a daily basis, we need to retrain it on new data. It means that it can't hold too many parameters, because then the length of the training process will not allow us to use such models for emerging threats. And there's a lot of problems in how to build robust models that can actually be used for such use cases, and be responsive enough, and be scalable enough, and be accurate enough for this particular use case. But this is not really an industry-wide problem. This is, I would say, more of a me problem in trying to build such models. Another thing that we need to keep in mind is that organizational patterns vary vastly from one to another. So if you're using internal cloud patterns, for example, if you're using some guidelines on how an application should look like, we would expect our remediation fixes to match that particular architecture. We would expect the AI to propose the same kind of changes that an engineer would. So to do that, we need to train it on a lot of data that sometimes is internal to our organization. In many industries, companies are sort of reluctant to share their intellectual property to that level. But to really be able to build a powerful model, we will need to be able to train it from many different kinds of code bases and many data sources. But again, there's still a road ahead until we get to that place as an industry. So I think the bottom line here is that yes, generative AI is amazing, but it won't fix all of our vulnerabilities automatically, at least not in the very near future by itself. I think that instrumentation can help us focus the results on the outcomes that we expect. And I think that the model that I sketched here is just a very simple one to start with. There's much more advanced ones to be able to make sure that the results are what we intended, and sort of guardrail the model around the outputs that would actually build the right fixes and improve our security. But I think that just like with autonomous vehicles, autonomous remediation may start as sort of frowned upon. And the primary challenge that we have is to be able to build trust, to be able to adopt this. We need everyone to gain the right level of confidence to say, hey, I want to use that model all the time, and I want to use that model in a way that doesn't even need my involvement as a part of that process. I think it will definitely take us a few years as an industry to get there. I think most enterprises are not quite ready yet because of many other dependencies, like the level of automation around CI/CD pipelines, making sure that they have a good test harness to support this, legal and compliance risks, which we talked briefly about, some level of standardization, because there's quite a bit of different technologies that do all of the different bits and pieces of that puzzle. But I think that even in this very brief presentation, we talked about quite a bit of parts of the process, quite a bit of pieces that we can benefit from today. If we think about the overall process from the point in time that a vulnerability is discovered up to the point it's fixed, I think AI is definitely helping us accelerate that process. We can accelerate the speed of the remediation and reduce the cost of fixing vulnerabilities, and benefit from these advancements even today. What I would encourage you to think about is how can we build a platform for autonomous remediation in the future. We need to decide how the process looks like. We need to integrate some of these first steps into the process and benefit from them immediately. And over time, we'll see the remediation process accelerates more and more. With that, I'd like to thank you for listening in. My email is here on the slide, tomer@daz.io. I'd love to chat more on cloud security remediation and about AI. So feel free to drop me a line if you have any questions or comments or just want to chat some more. Thank you.